Hello and welcome to section 4.5, which is on isosceles and equilateral triangles. So some basic definitions to go over. When they're talking about legs, they're talking about the congruent sides of an isosceles triangle. The base would be the third side of that isosceles triangle, the side that's not equal to the other two. A vertex angle would be formed by the two congruent sides of an isosceles triangle. And the base angle would be the two angles formed at the base of the triangle. Theorem 4.3, isosceles triangle theorem. If two sides of a triangle are congruent, then the angles opposite those sides are congruent also. Theorem 4.4, converse of the isosceles, apparently I can't spell, isosceles triangle theorem. If two sides of a triangle are congruent, then the sides opposite those angles are congruent. I should say two angles. There we go. So this one said if the sides are congruent, then the angles opposite the sides are congruent. This one says if the angles are congruent, then the sides opposite would be congruent. So they're the opposite of each other. That's why this is called the converse of that one. My example that I have here is angle WVS. This one right here, congruent to angle S, which is this one, and is side TR, this whole side, congruent to TS, and then to explain it. So looking at the marks that are given and going through everything we know, I would say that yes, because WV is congruent to WS. I have those marks right here. I know then that this angle and this angle would be equal because that's what this theorem says. These two sides are equal, therefore the angles opposite those sides, which would be this one and this one, would be equal also by the isosceles triangle theorem. And then since WVS is congruent to angle S and angle R is congruent to WVS, because that was given, I had that right here, I had it marked. Angle R is congruent to angle S by the transitive property of congruence. Therefore, TR is congruent to TS by the converse of the isosceles triangle theorem. Because this one is congruent to this one, that would make this side right here congruent to this side. That's this converse theorem. Theorem 4-5, if a line bisects the vertex angle of an isosceles triangle, then the line is also the perpendicular bisector of the base. So right here is an isosceles triangle, and then I have an angle bisector right here. This is the vertex angle because these two sides are marked as congruent, and it said that the vertex angle is the angle connecting those two congruent sides, so it would be this angle. And if I have something bisecting it right there, you have an equal angles there and there. So I want to find the values of x and y. So x is this side over here, and then, excuse me, that's y, and then x is this angle right here. So to find the angle, I have a 52-degree angle marked right here. And this one is marked as a right angle, which would mean this one over here also is right. So 90 plus 52 is 142. You subtract that from 180 because every triangle has 180 degrees in it. And what you have left is 38 degrees. So this angle x right here would be 38 degrees. And the y is actually pretty simple. It has to be 4 because this is a vertex angle. It means that the line drawn through here, if that bisects it, then it's the perpendicular bisector, which means these two have to be equal to each other. It's bisecting the line across from it. Corollary, a theorem that can be proved easily using another theorem. So the corollary to theorem 4.3. If a triangle is equilateral, then the triangle is also equiangular. What does that mean? It means if all three sides are equal, all three angles also have to be equal. The corollary to theorem 4.4, if a triangle is equiangular, then the triangle is equilateral. So it's just the flip of what I just said. If it has 3 equal angles, it also has to have 3 equal sides. Again, fairly common sense, but there actually is a rule for that. So here, if I'm going to use that information to solve a proof, so it says if a triangle, or excuse me, supply the missing information, then write the proof. So begin with triangle PRQ, where angle P is congruent to angle Q. Draw blank. We need to fill that in. Draw what? We need to draw side RS, which would be the bisector of PRQ. So given that angle P is congruent to angle Q, then blank bisects PRQ. So we need to fill in RS there, because that's the side that would complete that thought. And my picture is missing, so hang on a second and I will draw that in. Okay, so here is the drawing to go with that. It probably would have made more sense to have that before I went through this, but that's how I got the RS here. It says draw RS, so RS is the perpendicular bisector, and so RS bisects PRQ. That's the information you need to be able to finish this proof. So I want to prove that PR is congruent to QR. That PR right here is congruent to QR on this side. So I started with angle P is congruent to angle Q. That's given information. And then the next step, I went that RS is congruent to RS. It would have to be, right? The side has to be equal to itself. So RS is congruent to RS, which rule was that said that it was equal to itself? That was the reflexive property, that a side equals itself or an angle equals itself. So then from there, I said that angle PRS is congruent to angle QRS. How do I know that? Definition of angle bisector. Then from there, I said that triangle PRS is congruent to triangle QRS. So the one on the left-hand side is congruent to the one on the right-hand side. And how do I know that? The AAS theorem. Angle side. How do I know that? I know that this angle equals this angle. And because this bisected right here, I know that this angle equals this angle. And I know that this side equals this side. So I have an angle, and a side. And then I said PR is congruent to QR because corresponding parts of congruent triangles are congruent. That was a long one, but there you go. Corresponding parts of congruent triangles are congruent. That's how I know that PR is equal to QR. I went through and proved what I needed to prove to be able to say that. So bring that information with you, and we will talk more about triangles the next time I see you. Have a good night.